Welcome to The Explainer. Today, we're going to look at the world around us in a thrilling, completely new way. Let's kind of just turn down the lights for a second and prepare to investigate some of the absolute most mesmerizing optical mysteries the universe has to offer.
I want you to picture a totally impossible scenario. You're standing out in the freezing, isolated wilderness. You check your watch, and it's the dead of night, exactly 2 a.m. You look up into the sky, expecting to see, nothing but pitch blackness, but instead, suspended right there in the air is a ghostly, glowing, pure white rainbow. No red, no blue, no violet at all, just a phantom arch of white light. Now, does that sound like a scene straight out of a sci-fi movie? Well, I promise you, it's a very real documented event. But to understand how something so impossible could exist, we gotta follow the clues.
You see, physics absolutely loves to defy our common sense. It actually delights in the clash between our basic intuitions and absolute reality. The truth is, nature leaves clues to its greatest secrets sitting right in plain sight, hiding them inside phenomena we think are, well, completely ordinary. So to solve this late-night mystery of our phantom white rainbow, we first have to interrogate a suspect we all think we know perfectly well, the standard everyday rainbow.
Okay, let's dive into this. To figure this out, we have to look at the rules. Think of it like a locked room mystery. For a rainbow to manifest at all, the universe demands 3 strict, non-negotiable physical conditions. First, the sun has to be positioned exactly behind you. Second, there must be water droplets, like rain, fog, or mist, suspended in the air right in front of you. And third, there's got to be an absolutely clear path for the sunlight to reach those droplets without being blocked by clouds. It's a highly choreographed setup, right? But what exactly happens when that light finally hits the water?
Well, the secret lies in a mechanism called physical refraction. It was actually the philosopher René Descartes back in 1637 who cracked this code, way before we had modern lasers or computers. When white sunlight hits a suspended raindrop, that tiny little drop basically acts as a microscopic prism. The light enters the water and bends, or refracts, because water is denser than air. Then it reflects off the back wall of the droplet and finally bends one last time as it exits. Because different colors travel at slightly different wavelengths, the white light physically splits, fanning out into those distinct bands of color we all recognize: red, orange, yellow, green, blue, indigo, and violet.
But here is where the illusion starts to get a little eerie. Next time you witness a rainbow, I want you to look really closely at a detail that almost everyone completely misses. Look at the sky right above the top red band of the rainbow, and then check out the sky underneath the bottom violet band. You're going to notice something strange. The sky is noticeably, significantly darker on the outside of the rainbow than it is on the inside. Now, why on earth would a rainbow cast a shadow across the sky?
The answer lies in a rigid, mathematical boundary. Exactly 42 degrees. You see, when light enters these tiny water droplets, it fractures and scatters. Many of those light rays bounce around and exit the droplet at angles less than 40 degrees. Because so many different light waves are mixing together at these smaller angles, they actually merge back into a bright, glowing white light, which is what illuminates the sky beneath the arch. However, absolutely no light can escape the droplet at an angle greater than 42 degrees. Literally none. It's a physical impossibility. So that entire area above the 42-degree mark just becomes a dark, unlit void in the sky.
But nature loves to double down on its illusions. You've probably seen a double rainbow before, a fainter, second arch sitting high above that dark 42-degree void. This happens when the light doesn't just reflect once inside the raindrop, but actually bounces a second time before escaping. Now, what's really interesting about this is that it causes something totally mesmerizing. The second bow projects its colors in complete reverse. The primary bow has red on the outside and violet on the inside. But the double bow? It's flipped. Violet on the outside, red on the inside. It's literally a faint, mirrored ghost of the original.
And the physics don't just stop at 2. Our sky is actually haunted by invisible phantoms. Scientists have confirmed that third and even fourth rainbows regularly form up there, bouncing 3 or 4 times inside the droplets. We just can't see them. With every single bounce, the light loses energy, making these higher-order rainbows so incredibly faint that the naked human eye simply cannot detect them, unless the atmospheric conditions are impossibly perfect. But they're there, happening right in front of you, entirely unseen.
And the illusion completely changes depending on your perspective. We're so used to seeing a rainbow as an arch, just a half circle anchored to the Earth. But the Earth is really just getting in the way. If you were a pilot flying high above the clouds, with the sun behind your aircraft and the rain directly below you, you wouldn't see an arch at all. You would see the rainbow's true, almost terrifyingly perfect form, a complete, unbroken, closed circle of light just suspended in the air.
Which brings us right back to our ultimate mystery, the 2 a.m. phantom bow. Back in the mid-1970s, a student named Carl Wiles was stationed on Fletcher's Ice Island. This was a massive drifting iceberg roughly 300 miles from the North Pole. During the absolute peak of the Arctic summer, the sun never fully sets. It just hovers incredibly low on the horizon, even at 2 in the morning. Wiles looked up and managed to photograph a ghostly, glowing white rainbow in the freezing mist. No colors, just pure white. How did the strict, unbending laws of physics allow this impossible sight to manifest?
Well, the answer lies in the microscopic scale. So the crucial point is, for this illusion to work, which is often called a fog bow, by the way, the water droplets in the air must be unimaginably tiny. We're talking specifically smaller than 40 microns in radius. When light enters a droplet that small, a phenomenon called diffraction takes over. The distinct color waves of light are forced to spread out so widely and violently that they actually overlap and physically interfere with one another. Because all those separated colors cross over and mix back together, they completely wash each other out, merging right back into pure, brilliant white.
And this brilliantly illustrates a really profound truth about physics. The universe operates on delicate, completely hidden balances. Think of a Newton's cradle, right? Where pulling back one steel sphere perfectly transfers kinetic energy to launch exactly one sphere on the opposite side. If you pull back 2, exactly 2 will launch. It's an unbending law of conservation. Just like that kinetic energy perfectly transferring through those steel balls, the light and water in our atmosphere interact in a precise mathematical harmony to conjure these spectral illusions.
In fact, the exact same rules of refraction that conjure a glowing white rainbow in the freezing Arctic also conjure ghosts out in the boiling desert. Just consider the mirage. When extreme heat radiates off the desert sand, it drastically alters the density of the air layers right above the ground. As sunlight travels down through those varying densities, it gets continuously bent, or refracted, upwards toward the viewer's eye. This literally tricks our brain into seeing a shimmering pool of water, or an inverted reflection of the sky sitting right there on the sand. It's a phantom projection constructed entirely out of bent light and hot air. Nature isn't trying to trick us to be cruel. As Albert Einstein famously remarked, God is subtle, but is not malicious. The universe wraps its most breathtaking secrets inside strict, uncompromising physical laws. Whether it's a dark void at a 42-degree angle, a phantom double bow reversing its colors, or a glowing white arch suspended in the freezing Arctic night, these aren't just beautiful accidents. They're the hidden codes of reality revealing themselves for just a fraction of a second. So I leave you with this thought. The next time you step outside, what other invisible phantoms are hiding right now in the light around you, just waiting for you to look closely enough to see them?